Welcome to this session, Who's Managing the Credentials for Your Data Infrastructure? My name is Dewan Ahmed. I'm a developer advocate at Ivan. We build and manage your data infrastructure using open source technologies so that you can focus on your critical applications. I'm from the beautiful New Brunswick, Canada, which is in the East Coast. I focus on application and data infrastructure. In my free time, I'm a pro bono career coach where I help students and new grads to start a career in the software industry. Today, we'll focus on the issue of shared password. Many of us might be part of similar interaction where we requested a password. This password is shared and reshared and it lives forever. We'll talk about database security and how managed database can help within database security. What are dynamic credentials and their benefits, your strategies in choosing the right secret management tool, and a demo. Database security is a vast field. Starts with physical access. Someone might actually run away with the disks, so you need to ensure the security of your physical data center. Your database is running on some bare metal or virtual machine. So if the host machine gets compromised, your database will also be compromised. There might be some SQL injection or insertion attacks via your application, and someone might be restarting your database or performing some update delete operations that they shouldn't be doing. And there are some other variations of these attacks as well. Because of all this, you might have data loss. Do you have a data backup? This also falls within database security. But today, we will not talk about any of these. Today, I want to talk about database access because 80% of data breaches are the result of poor or reused passwords. Now, what do I mean by database access? It starts with the A, authentication. Who can access your database? A, authorization. If someone has access, what actions they can perform. And the final A, who did what in your database you want to do an audit. This is very similar to network security, the AAA model. Now, managed database has a lot of benefits, but today my focus is security. So the host of the provider, the host where the database is running is managed. So you don't have to set up the host itself. And if you misconfigure the host, that can lead to some security vulnerability. The updates and patches both for the host and the database is taken care. So for example, there is some security vulnerability and there is a security team from the provider. And they're making sure that the patch is applied in due time. So you don't have to manually rush and see what are the latest security issues and patch your own host or the database. When you have a large fleet of resources, you want consistency because inconsistency can lead to insecurity. So many providers allow usage of infrastructure as code tools where you can create your infrastructure using tools like Terraform, and that can lead to consistency. And finally, in case anything happens, you want the option to have backups. So many managed database providers offer backups and disaster recovery as well. Now, what is a dynamic credential? A dynamic credential is generated on demand. It didn't exist before. So imagine an application only needs to talk to your database for 60 seconds, or your application developer is working for 8 hours and need access for that 8 hours. You can generate dynamic credential based on time and whenever that is required. And whoever requested that credential, that can also be audited. Some of the issues it tackles is secret sprawl, where you have secrets everywhere. Some remote server running a copy of your application, or your existing employee, or an employee who already left the company. You actually don't know who has access to your database anymore. And you also have same database credential everywhere. Your developer and your applications are using the same password. But even with following all the precautions, breaches can happen. And what do you do when there is a breach? Do you have a break glass procedure? That is a bypass mechanism to access your resources in case something happens. For some companies, that might mean printing the admin-like passwords and putting it into a physical safe. And only certain employees might have access to that password. And let's say if the secret management tool, the server goes down and you can no longer access the database, or some data center goes down, you can use that bypass mechanism to still access your data and database. Now let's talk about choosing the right tool and what could be the strategy. So your developers love flexibility. So the tool has to allow different ways of talking to it, whether it's using a CLI or UI, using some libraries. And you don't want to use different tools for different resources. For example, you might be using AWS, Google Cloud, some different database. You don't want a different tool for every different secret management. Ideally, you want one tool that can manage secrets for all these providers. Since the tool will be handling secrets and sensitive data, encryption probably is on the top of your list. And the tokens or secrets that would be generated by the tool, you want the automatic expiry option as well. In case something happens, like a breach, you want the ability to revoke passwords for some specific resources. HashiCorp Vault, which is part of an open source project, has checkmark for all the requirements which we just mentioned. Now, this is not the only option you have. You're free to choose any secret management tool, but this is something I'm talking about in today's demo, which seems to meet all these requirements. So you can interact with Vault using the HTTP API, CLI, or UI. You have secret engines for various cloud providers, all the major cloud providers, multiple databases, PostgreSQL, which we'll see in today's demo. And Vault offers encryption as a service. So your application can generate plain text secrets, pass it to Vault, and Vault can take care of the encryption. And then you can use that. Let's say you can store that in an S3 bucket or some other usage, but Vault could do the encryption for you. Vault can also store long-lived secrets. It can manage or revoke leases on those secrets as well. You can specify different roles or permissions, and the credentials would be generated based on those roles. You can use Vault as an intermediate CA or even a root CA, and it will help you not needing to set up an X509 certificate yourself, which you have done. You know it's quite a pain to do it yourself. And even the open source version of Vault allows high availability. You can run Vault in cluster, and that's something what we're mentioning about break glass procedure. What happens if the server running Vault goes down? So you actually have high availability built in. So if the primary server goes down, you have the backup or secondary Vault server. So high availability here leads to more secure operation. So this is showing a database usage or database access without Vault or without any secret management tool. So you have a database password, you are asking data, and you're getting the data. Plain and simple, but not so secure. And this is using Vault. So you have to authenticate to Vault first. So that could be set up using single sign-on, or LDAP or other authentication providers. Once you or your application authenticates to Vault, Vault would know the different secret engines that are configured, and it would validate that those credentials are valid. And once you request a dynamic credential, Vault will know what is the role associated to that user or app, and Vault would generate credential based on that role. So it's scoped, limited, and also it has a TTL, a specific time to leave. After that, that credential will no longer work. And finally, you can, or your application can connect to your resource. Here is a database using that dynamic credential. All right, so I think now we can jump into the demo. So I have Vault Server running on my local machine, and this is running in development mode, which should not be used in production. I have the Vault Server unsealed, which basically means I can use and talk to Vault. And the first step is I have to export the address of the Vault Server so that my terminal knows where is the Vault. I'm also using a PostgreSQL database. So this is Ivan for PostgreSQL running on Ivan platform, but this is for demo purpose. You can use whichever database that fits your need. So once I connect it to the database, I'd like to show you two tables. And this is related to our today's story. The story is a story of an application. This application fetches different websites and gathers these metrics, and it creates a report. So that app only needs to have access to the weekly metrics reporting table, nothing else. Because I'm using an admin password, I can also see the employee salary and the sensitive information. So at the end of the demo, we'd like to limit the access to only the weekly matrix reporting table. Hopefully we can do that. So I'll start using Vault now. So the first step of using the Vault is I have to enable a secret engine. And by default, the name of the secret engine are just the name of, let's say if it's a database secret engine, it's database. If you're using AWS secret engine, it would be Vault secrets enable AWS. The next step is I have to configure this secret engine. So Vault write database is the command, and I'm mentioning this specific role and the connection URL. Best practices would be not to hard code the username and password here, rather than use it as template, and the actual value is coming from here. Because by the time you'll see this demo, these credentials will not be working. So I'd like to show you what's under the hood, what's under this service underscore password as well. So this is something that is only telling Vault that create this role, but the previous command didn't tell Vault about the scope or what the metrics read write role can do. This is the command where I'm telling Vault that for the default DB database, grant all operation on weekly matrix reporting table. So only this table, and the credentials will have a time to live or expiry of 1 hour, and you can renew it up to 24 hours. So these are the only two configurations we needed. So once I have it, I can actually start requesting dynamic credentials from Vault. So I have this dynamic username and password, which didn't exist a few seconds ago. Now it exists, and it will live for 1 hour. Let's try to connect to our PostgreSQL instance using this dynamic credential. All right, so I'm in, and now let's see if we can read these two tables. So for the sake of our story, we should be able to read the weekly matrix reporting table, and we can read this table. But we should not be able to read the employee salary table, which contains sensitive data. And we can see that the permission is denied for employee salary table. So this covers the authentication and the authorization part. Now let's go into the auditing part. So in order to enable auditing, the command is vault audit enable, and this is the auditing enabled in this specific path. So now if we view this file, we should be able to see every single interaction with the Vault server. So here we can see different interaction with the Vault server, including the username and passwords that were generated. So because this is a log file, Vault does not store username and password in plain text. It hashes using HMAC, and you can actually validate it yourself using the same audit device and generating the HMACs yourself. The other part that you might be wondering, that we requested credentials using Vault Read database, but how can your developers use this command within their programming language? For that, you can use the HTTP API command. So let me find the curl command. And I need to pass the token here, which is the root token. And this is for demo. When you're using Vault in production, you would have a token with much least privilege. So if you see that, now I used a curl command to request a dynamic credential. So this gets to show that any modern programming language, as long as you can make an HTTP request, you can use Vault. So now let's go back to our presentation and see what did we cover today. So in today's talk, we talked about database security. We saw different pieces of database security and focused on database access. We also discussed how managed databases can help with database security, because the host is managed, the patches and updates are managed for you, and you can orchestrate your data infrastructure rather than click opsing. We learned about dynamic credentials and how dynamic credentials can help you generate credentials on demand with time-bound access, and also you can audit your activity. For the demo, we covered Ivan for PostgreSQL and HashiCorp Vault to generate dynamic database credentials. And the sample applications we had, it should have access to a specific table, and it should not have access to another table, which we saw during the demo. We also saw how we can enable auditing and have a trail of all the interactions within our secret management tool. If you'd like to learn more about Ivan for PostgreSQL or HashiCorp Vault, these are the documentation. Thank you so much for attending this session, and I'd love to connect with you. My LinkedIn and Twitter handles are on the bottom right corner of the screen.